Hello, students, and welcome to our May 12th lesson. And if you are in my fifth period class, this will be your May 13th lesson. Remember to turn in your vector form mini project. We have a do now that you need to respond to, and today we will solve quadratic equations by factoring. For homework, I want you to do homework number 5, solving quadratics by factoring, and we'll be doing this again the next time we meet. For your exit ticket today, I want you to check PowerSchool and Teams for any Unit 7 assignments because they will be removed from PowerSchool, and once they are, zeros will be entered. So let's get that work done. Today is School Nurse Day. Nurses can be very compassionate. They are often with families during times of great joy and times of great sorrow. Can you imagine yourself in a career that requires that level of compassion? Think about that and answer that right there. So let's talk about these quadratics. So we've done a lot of factoring over the last few weeks. In many cases, we can find the solutions. Remember, those are the roots, the zeros, or the x-intercepts of a quadratic equation by factoring rather than graphing. So we're going to follow the steps below to find the solutions of the given equation by factoring. So we are given the quadratic y equals x squared plus 3x minus 10, and we've got 4 simple steps. First, we need to set the quadratic equal to 0. So I'll do that now. X squared plus 3x minus 10 equals 0. Then we're going to factor that left side of the quadratic. And when we factor it, we need two numbers that add to 3 and multiply to negative 10, and that would be 5 and negative 2. So we'll factor that quadratic, x plus 5 and x minus 2 equals 0. Now, the next step is something new. We're going to set each factor equal to 0 and solve each factor for x. So we'll make a t, and we have x plus 5 equals 0, and x minus 2 equals 0. So in the first case, on the left, x will equal negative 5, and on the right, x will equal 2. So then we can write our answer in set notation using those curly braces. X equals the set of all numbers such that x equals negative 5 and positive 2. And that's our final answer. So that is solving quadratics using simplified factoring. So let's try these problems and let's see how we do. We have 22 problems. The 16 of them are in standard form, and 6 of them are not in standard form. So we will have to put those in standard form using our algebra toolbox. So number 1, we need two numbers that add to 4 and multiply to 3. So that would be a positive, and they're going to be positive and positive. So it would be positive 3 and positive 1. So that would be x plus 3 and x plus 1 equals 0. So x plus 3 equals 0, x plus 1 equals 0. In the left side, x equals negative 3. On the right side, x equals negative 1. Let me write that so you can understand it a little better. So those are our two solutions. This is a two-solution quadratic. Now, if we were to use find the discriminant, we would find that the discriminant is greater than 0, thus indicating that we have two solutions. And those solutions are the set of all numbers such that x equals negative 3 or negative 1. So number 2, x squared plus 11x plus 24 equals 0. Two numbers that add to 11 and multiply to 24, and they'll both be positive, and those numbers are 8 and 3. So x plus 8 and x plus 3 equal 0. We'll solve each one of those separately after we set them equal to 0. X plus 8 equals 0. X plus 3 equals 0. So on the left side, x equals -8, and on the right side, x equals -3. And that would be our solution set. X equals the set of all numbers such that x equals -8 and -3. And let's make sure to box our answers so they're easily identified. So let's see, perhaps you could try 3 through 8 yourself and then come back, or maybe you could try them one at a time and then come back to the video. But I will keep working. So we need two numbers that add to 1 and +1 and multiply to -2. That means we need a positive and a negative. The positive number will be larger, absolute value, so that would be a 2 and a -1. So x plus 2 and x minus 1 equal 0. So x plus 2 equals 0 and x equals -2. X minus 1 equals 0 and x equals +1. So our solution is the set of all numbers for x such that x equals -2 and +1. Okay, number 4, x squared plus 6x minus 27 equals 0. I need two numbers that add to 6 and multiply to -27, and it's going to be a positive and a negative. The positive number will have the greater absolute value, and that means we can use a 9 and a -3. X plus 9, x minus 3 equals 0. Now we'll set each one of those individually to equal 0. And in this case, x will equal -9. And on the left side, x will equal +3. So our answer will be these two solutions, -9 and +3, indicating that our parabola will cross the x-axis in those two places. Number 5, x squared minus 10x plus 21 equals 0. I need two numbers that add to -10 and multiply to 21. The negative number, there will be both negative numbers because we need them to multiply to +21. So that would be -7 and -3. So x minus 7, x minus 3 equals 0. So x minus 7 equals 0. So therefore x equals 7. And x minus 3 equals 0. Therefore x equals +3. And those are our two solutions. Let's put them in order. And there we go. So number 6, x squared minus x minus 20 equals 0. We need two numbers that multiply to -1, that add to -1 and multiply to -20. So it will be a negative and a positive. The negative number will have the larger absolute value because of the -1 here. So that would be -5 and +4. So x minus 5, x plus 4 equals 0. It's our factored form. And then we'll set each one of those factors to 0. And in the left side, x equals positive 5, and on the right side, x equals negative 4. And those are our two solutions. Let's change our color for a few minutes. We'll work with the pink. So number 7, we have x squared plus 10x plus 25. We need two numbers that add to 10 and multiply to 25, and they'll both be positive. So certainly 5 and 5. They add to 10 and multiply to 25. So x plus 5, x plus 5 equals 0. And because of the technique that we're using, we're not going to do x plus 5 squared. We're going to go ahead and do them separately. And what we have is a one solution quadratic. So that quadratic, we know that it faces upward like a smile because of the positive x squared value. And we know that the vertex will be at x equals negative 5. So number 8, we need two numbers that add to negative 8 and multiply to positive 16. That means we need two negative numbers, so that would be negative 4 and negative 4. So x minus 4 equals 0. That's our factored form. So let's solve for x minus 4 equals 0. And again, similar to number 7, we have one solution. X equals 4. All right, so let's move on to the second page of problems. And let's take a look at those. Okay, so with some of these problems, we do not have a C value, but they're still in standard form, this next group of problems. So when we factor number 9, x squared minus 8x equals 0, we're simply going to factor out an x. So we have x times x minus 8 equals 0. Don't forget your factoring, but we can still solve this in a similar fashion. On the left side, we have x equals 0. On the right side, we have x minus 8 equals 0, x equals positive 8. So we do have two solutions. We have the set of all numbers such that x equals 0 or 8. And number 10 is somewhat similar, but we do have that 3 and the 3x squared plus 15x equals 0. So we'll factor out the 3x, which leaves us with x plus 5 equals 0. So we have on the left side, we have 3x equals 0, which means x equals 0. And on the right side, we have x plus 5 equals 0. So x equals negative 5. So our two solutions, x equals negative 5, 0. And let's take a look at number 11. I'd like you to try 11 through 16 by yourself. I think that would be good practice, and then come back to the video. Okay, so I'm going to work on number 11, and I'm going to factor out 6x, which leaves me with x minus 2 equals 0. So 6 x equals 0, which means x equals 0 on the left. On the right, x minus 2 equals 0, which means that x equals a positive 2. So our solutions are 0 and positive 2. In number 12, let's factor out a 2x, which leaves us with x minus 3 4x, minus 3 equals 0 on the right side. Let me just rewrite that a little more neatly so you can read it. So we're factoring out the 2x, which leaves us with 4x minus 3 equals 0. So 2x equals 0, so x equals 0. 4x minus 3 equals 0. We add 3 to both sides. 4x equals 3. And we divide both sides by 4. X equals 3/4. So our two solutions are 0 and 3/4. Okay, you're going to have some fractions sometimes. Number 13, we have x squared minus 64 equals 0, and that is a difference of squares. So let's see if you remember, that's x plus 8 and x minus 8 equals 0. So x plus 8 equals 0. X equals negative 8. With x minus 8 equals 0, x equals positive 8. And those are our two solutions. And we also have a difference of squares with number 14. So that would be x plus 5, x minus 5 equals 0. So let's solve both of those. X plus 5 equals 0, and x equals negative 5. And with x minus 5 equals 0, x equals positive 5. And those are our two solutions. Okay, number 15. This one will factor out to, we can take 2x minus 9, 2x plus 9. You could factor almost by grouping. So let's solve each of these separately. We subtract 9 from both sides. 2x equals negative 9. And x equals, we divide by 2, negative 9 over 2. And on the second side, the right side, we add 9 to both sides. And x will equal positive 9 over 2. And those are our two solutions. And number 16, we have to move, I'm sorry, number 16. Number 16, we can factor that to 3x plus and minus 7, difference of squares again. These four, 13, 14, 15, and 16, are all difference of squares. So 3x plus 7, 3x minus 7 equals 0. So we'll set each one separately to 0 and solve for x. Subtract 7 from both sides. 3x equals negative 7. X equals, when I divide by 3, negative 7 over 3. And on the right side, we'll add 7 to both sides. 3x equals a positive 7, so x would equal positive 7 over 3. We'll leave those in proper fractions, and we'll write our answer set. Okay, so now those last 6 problems are not in standard form. So first we have to put them in standard form. All we need to do in number 17, x squared plus 4x equals 21, is subtract 21 from both sides and set the equation to 0, which will give us x squared plus 4x minus 21 equals 0. And we need two numbers, a positive and a negative, that add to 7 and multiply to 21, and that would be a positive 7 and a negative 3. Or add to 4, excuse me, and multiply to negative 21. So that would be positive 7 and a negative 3. X plus 7, x minus 3 equals 0. And we'll solve x plus 7 equals 0 and x equals negative 7. And we'll solve x minus 3 equals 0 and x equals 3. And that is our solution set. Number 18. Again, we're going to move that 4x to the left side. And we will have x squared minus 45 minus 4x. So we're going to need a positive and a negative number that add to let me rewrite that. We're going to add to 4x and multiply to 45, but I want to write it in standard form. So let's do that. Minus 4x next, minus 45. Okay, a positive and a negative number is what we'll need to add to 4 and multiply to 45, and the negative number will have a larger absolute value, so that would be negative 9 and a positive 5. So x minus 9, x plus 5 equals 0. And let's solve. X minus 9 equals 0, and x plus 5 equals 0. On the left side, x equals a positive 9. On the right side, x equals a negative 5. And that is our solution set. Number 19. We have to combine some like terms. We have negative 5x, and we have a positive 7x, but when we bring that positive 7x over here, it will be a negative 7x. So we need to combine negative 7x and negative 5x, which will be negative 12x minus 64, our constant. So we need two numbers that add to negative 12 and multiply to negative 64. So we would need a negative and a positive number. The negative number will be larger. So 12 times 16. 16 times 4 is 64. So if we have a negative 16 and a positive 4, that will work for us because negative 16, positive 4 add to negative 12 and multiply to negative 64. So x minus 16, x plus 4 equals 0. So x minus 16 equals 0, and x plus 4 equals 0. So on the left side, x equals 16, and on the right side, x equals negative 4, and that's our answer set. X equals negative 4, positive 16. It's a two-solution quadratic. The parabola crosses the x-axis in two places. Now, number 20, we need to move 4x over, so that would be a negative 4x, and we need to move the 1 over, and that would be a negative 1. So when we put it together, we're going to have x squared minus 14x plus 48 equals 0. And two numbers that add to negative 14 and multiply to positive 48 will be two negative numbers. That would be a negative 8 and a negative 6. That would add to negative 14 and multiply to positive 48. So x minus 8, x minus 6 equals 0. And let's solve each of those factors separately. X minus 8 equals 0, x minus 6 equals 0. And on the left side, we have x equals 8, and on the right side, x equals 6. And those are our two solutions. And number 21, we do not have a constant, but we do have, when we move x squared over the 1x squared over to the left side, that's going to give us 10x squared because we will be subtracting 1. And when we move the 8x over, that would be a negative 8x equals 0. And then we'll just simply factor out 2x, which would leave us with 5x minus 4. So 2x times 5x minus 4 equals 0. We'll solve each side. So 2x equals 0. That means that x equals 0. 5x minus 4 equals 0. We add 4 to both sides. 5x equals 4, and x would equal 4/5. So our two solutions, x equals 0 or 4/5. And finally, number 22. I'm pretty sure we're going to have some fractions here. So let's move the 9 over. That would give us 16x squared minus 9 equals 0. And we can factor that difference of squares. So that's 4x plus 3, 4x minus 3 equals 0. So let's solve each one of those factors. So on the left side, we will subtract 3 from each side. 4x equals negative 3. Therefore, when we divide both sides by 4, x equals negative 3/4. And on the right side, we'll add 3 to both sides. So 4x equals a positive 3. When we divide both sides by 4, x equals a positive 3/4. Those are our two solutions. So x equals negative 3/4, positive 3/4. And our work is done. Please do your homework tonight. You have 20 problems, and they're very similar to the ones we just did. And if you want to check last night's homework, there are the solutions for last night's homework. And if you're looking for a little fun activity to take a break today, we have pixel art, and we have, in honor of our school nurses today, we have a word search. So good job today. You have just solved your first quadratics. This is a big moment in algebra. Remember to follow those 4 steps. Don't forget your factoring rules. Get lots of practice, and you will certainly be great.